Concept is center of mass or center of gravity. The center of gravity of a body is the point at which the body is balanced, or the point through which the weight of the body is acting. So it is actually the point at which we can balance the body. So the location of center of gravity of a body coincides with the center of mass if the dimensions of the body are much smaller than those of Earth. So all the structural members or the shapes on the Earth, their dimension is very small as compared to the dimensions of Earth. So we can say that their center of mass as well as the center of gravity coincides with each other. So when the density of a body is uniform throughout, the center of mass and the centroid of the body are at the same point. The centroid as well as the center of mass will be same if the thickness as well as the density of the member is same. The center of mass or center of gravity is the point about which we can balance the member or balance the body. So here we have our demonstration. We can balance this fork and spoon at the edge of the glass. This is because the center of mass of these two is lying over here. So we can balance it at this point. Similar demonstration is in this case. We can balance these forks with a cork and a needle at the edge of the bottle. So again, this is because the center of mass of this assembly is acting at the end of this needle. There is very important information related to center of mass which can be used for the design of structure, which is if the center of mass of a body is not positioned above the area over which it is supported, the body will topple over. So if, for example, this is a structure, here is its center of mass, it is acting over here, and this is its supported area. So as the line of action of this center of mass as the weight is passing through this supported area, so it will be stable. But if we turn it like this, and if this center of mass or the line of action of this weight is out of this area which is supporting this structure, so in that case this structure will topple over. The lower the center of mass of a body, the lower or the more stable will be the body. And if larger the supporting area of the body, more stable will be the body. So if we increase the supporting area, so we can make the structure stable, as well as if we lower its mass center, then again by lowering the mass center we can also make it stable. So here we have demonstration for these two concepts or for these 2 points. For example, we have this rectangular body, a tower and a pyramid type structure. So at this stage their center of mass is over here and the line of action of weight is in this direction. So the center of mass in case of this rectangle is lying at the center, and in case of this pyramid it is lying at 2/3 from the top or 1/3 from the bottom. So if we rotate its base like this, so first of all this structure or this rectangular structure will fall down, this will topple over. This is because as the center of mass is high, so just with a small rotation this will come out of the supported area. So the line of action of its weight will go outside the supported area, so it will topple over. The critical angle or the topple angle will be almost 15 degrees centigrade, 15 degree. And if we further increase its topple angle, the inclination of its base, so then this second shape will topple. This with the further increase in the inclination angle, this weight, the line of action of weight will go away from the supported area and this structure will fall down. So here in this case both the structure have same supported area, but the structure with higher center of mass will topple first. And if we compare these two structures, both have same height, same shape, so it means their center of mass will lie at the same height. But in case of second shape we have higher supported area. So in case of second shape, because of higher supported area, so it will topple at the later at the higher inclination angle. So if we summarize these three models, so this model will topple first at 15 degree angle, this model will topple at 30 degree, and this will topple at about, so this is at 10 degree, this is at 20 degree, and this is at 30 degree. So here the difference was the height of the center of mass, and here the difference was the supporting area. Lower the center of mass, more will be the stability of the structure. Similarly, higher the supporting area, more will be the stability of structure. So this concept of center of mass is used for the design of different structures. For example, in case of Eiffel Tower, the base of the structure is enhanced. This is to lower down the center of mass. So when the center of mass is lower, so it will not topple because of earthquake loads or wind loads. Similarly, if we see this shoe rack in the market, so alone it can topple because its center of mass will lie over here and it will be away from its supporting area, so it can topple. But if we want to make it stable, we need to increase its supporting area. So now this center of mass is passing through the supporting area, so it will become stable structure. Here if we see this structure, here the line of action of the mass or the center of mass will be over here, and it is passing from the supported area, so this structure will be stable. Visually it look like that it will topple over, but it will be a stable structure because the center of mass lies over the supporting area. So the last figure, this is very interesting to understand the concept of center of mass. So in case of tower crane, if we reduce this portion, so in that case the center of mass of this whole structure, including this weight and the weight of this beam, will lie somewhere over here, and this is away from the supporting area, so this structure will topple over. So either we need to increase this base or we need to shift the center of mass. So we cannot increase the base, the supporting area, because this tower crane is placed near to the structure, so we cannot enhance its support or its foundation inside the structure. So in that case, what we do, we add some counterweight at the back side. So by adding this counterweight, we have shifted the center of mass of the structure near to this tower, this vertical members, and this is passing through the supported area. So as a result, our tower crane will not topple over. And similarly, this also reduces the shift of bending moment into these vertical members. So as there is no bending moment, so no bending moment will be transferred to the foundation, and this structure will remain stable.